Hello everyone, in this video I am going to take examples of 8.2 question number 1. Example number 3, it is about tan theta 1 is equal to 1. Find out sin theta and cos theta. Let us draw here a right angle triangle PQR. Suppose the name of right angle triangle. Angle Q is a right angle, R has measure theta, and I'll write the definition of tan theta here. Tan theta is a ratio of opposite side PQ and adjacent side QR. Now PQ will be written as 1K, QR as again 1K, no number in the denominators, suppose 1. Then here K is a constant greater than 0. After this, I'll write, as the given triangle is right angle triangle, in triangle PQR, angle Q has measure 90 degree. Let us apply Pythagoras theorem. By applying Pythagoras theorem, we can write square of hypotenuse PR, square of one side PQ plus square of other side QR. PQ is 1K, square of the bracket. QR is 1K, square of the bracket. Square of 1 is 1, square of K is K square. Square of 1 is 1, square of K is K square. 1 plus 1 gives 2 K square. PR square is 2 K square. Let us obtain square root of PR square, it is PR. Square root of 2 is root 2 and K square root is K. We have got here PR as root 2 K. Now the two ratios let us obtain. The first ratio is sin theta. Opposite of theta is PQ and the hypotenuse is PR. We know PQ here as 1K. The hypotenuse is root 2K. K cancel them. We obtain 1 upon root 2. The next ratio is cos theta. We divide neighbor side QR and hypotenuse PR. 1K and the hypotenuse root 2K. We divide K and it becomes 1 upon root 2. After completing answer number 3, let us proceed further in this video for further answers also. In the table, fourth example is sin theta is given 1 upon 2. Find out other ratios. For getting other ratios, let us draw a right angle triangle. Element M is a right angle and has measure theta. Suppose definition of sine, opposite side LM, hypotenuse LN. I'll write here LM 1K, LN 2K, where K is a constant greater than 0. K is a constant greater than 0. LM 1K, LN 2K. Let us apply Pythagoras theorem now. In the given triangle LMN, M angle is a right angle. Therefore, by using Pythagoras theorem, we are going to write square of ln is equal to square of lm plus square of mn. Ln is the hypotenuse, 2k is number for hypotenuse. Lm is one side, 1k is the number. plus mn square. We are going to write here square of 2k as a 4k square, 1k square and mn square. We are going to minus in the next step two numbers for two terms like 4k square and 1k square. The difference of these two terms is becoming 3k square. Let us take the square root. It will give us root 3 for 3 square root and k square root is k. After getting mn, I'll write here root 3k is mn. We are going to find out other two ratios like cos theta and tan theta. Let us obtain now cos theta, where we write adjacent side mn and the hypotenuse ln. Root 3k and ln is 2k. K cancel. It become root 3 upon 2. Now we are going to obtain the last ratio tan theta, where we write opposite side lm and neighbor side mn. Lm upon mn. Lm is 1k and the mn is root 3k. We are obtaining here 1 upon root 3 for tan theta. After completing answer number 4, let us proceed further for example number 5. Example number 5, we have cos theta in the table as 1 upon root 3. For getting other two ratios by Pythagoras theorem, let us make a right angle triangle. Let us consider a triangle ABC is a right angle triangle here with angle B 90 degree, C measure theta. Cos theta, a ratio of adjacent side BC and hypotenuse AC. BC is 1k, AC is root 3k, where k is a constant greater than 0. I'll write here BC, a neighbor side of theta, AC, the hypotenuse of right angle triangle. Now we are going to write in triangle ABC, one angle B has measure 90 degree. Let us apply Pythagoras theorem. When we apply Pythagoras theorem, it can be written hypotenuse AC square is equal to one side AB square plus other side BC square. We know AC as root 3k square of the bracket. We know AB, no, it is not known to us. It is written as AB square. BC is 1k and the bracket square. Square of root 3 will be 3 and the k square. AB square plus square of 1 and square of k square. After this, for getting AB square, I'll minus 3k square and 1k square. It gives 2k square. Therefore, square root of AB square will become AB, square root of 2 will be root 2 and k square root is k. So, we get here root 2k for AB. Now, let us obtain ratio number 1 sin theta, a ratio of opposite side AB and hypotenuse AC. 2 root k upon AC root 3k. K cancel them. We get root 2 upon root 3. Now tan theta, we are going to get it by dividing opposite side of theta and adjacent side of theta. Root 2k and 1k. When we divide them, it becomes root 2. Answer number 5 we have completed. Now you have example number 6 where tan theta in the table is given as 21 upon 20. So a right angle triangle is always needed when you want to obtain the ratio by Pythagoras theorem. Let us draw a right angle triangle here. I am not getting right angle triangle. Let me call the given right angle triangle this time as PQR. This is suppose PQR, a right angle triangle. R angle theta in measure. Then write the definition of tan theta. It is opposite side PQ and adjacent side QR ratio known as tan theta. PQ, let us write 21K. QR, let us write 20K. And K is a constant. We are going to write here greater than 0. After this, PQ, let us show it 21K, opposite side, adjacent side 20K. In triangle PQR, there is one angle Q of measure 90 degree. Let us apply Pythagoras theorem. When we apply Pythagoras theorem, for the given triangle, hypotenuse will be written PR square, one side PQ square plus other side QR square. PQ 21K and the square of bracket, QR 20K and square of bracket, square of 21 441 K square, square of 20 400 K square. Then sum of these two number 841 K square. Let us take the square root of PR. Square become PR and 29K. After getting the hypotenuse 29K, the two ratios like sin theta we can easily obtain by writing PQ opposite side hypotenuse PR. 21K upon 29K. Cancel K, 21 upon 29. Then we have to get here cos theta. Divide the adjacent side QR and the hypotenuse PR. QR 20K and the hypotenuse is 29K. We obtain here 20 upon 29. Answer number 6 is done up. Now we have example number 7. Example number 7, we are again given tan theta as 8 upon 15. In order to get the other ratio like sine and cos, a right angle triangle, I will draw first. Let us call this time the right angle triangle as LMN. Angle M is right angle, N is theta in measure. Definition of tan means to write opposite side of theta LM and neighbor side MN, this ratio. Now we are going to write LM 8K, MN 15K, where K is a constant multiple greater than 0. It is greater than 0. LM, it is 8K, MN, it is 15K. Let us apply Pythagoras theorem. In triangle LMN, angle M has got measure like 90 degree. By Pythagoras theorem, square of ln, square of lm plus square of mn. I have to show this. This is known as Pythagoras theorem. Now I am going to write lm number 8K, square of it, then mn number 15K, square of it, and further we are going to write square of 8, 64, K square, 15 square 225 k square. Total of the two number 289 k square. And further, let us get the square root. It will give us 17k. ln 17k. Now we are going to write sin theta ratio, a ratio of opposite side ln and hypotenuse ln. 8k upon 17k. K cancel them. It become 8 upon 17. Let us get cos theta, a ratio of adjacent mn and hypotenuse ln. 15k and 17k. 15 upon 17. Example number 8, everyone. It is sin theta given 3 upon 5, and we have to find out cos theta and tan theta. Let us obtain cos theta and the tan theta by making a right angle triangle XYZ. Angle Y is right angle, angle Z theta in measure. What do you mean by sin theta? Sin theta means a ratio of opposite side for theta and hypotenuse XZ. XY will become then 3k and XZ will be written 5k. 3k, 5k. Here k is a constant greater than 0. Let us apply Pythagoras theorem now. In triangle XYZ, angle Y is 90 degree in measure. So when we apply Pythagoras theorem for the given right angle triangle XYZ, we are going to obtain square of XZ is equal to square of XY plus the square of YZ. XZ we have got 5k under bracket square, XY 3k under bracket square, YZ square we do not know. Square of Y 25k square, square of 3 9k square and YZ square. Further, for getting YZ square, we will write 25k square minus 9k square is equal to 16k square. Therefore, YZ is 4k. After getting YZ, let us obtain ratio like cos theta. Cos theta contain neighbor side YZ, hypotenuse XZ. Neighbor side 4k, hypotenuse 5k. 4 upon 5 is ratio cos theta. Last one, tan theta, contain a ratio of opposite side xy, neighbor side yz. 3k and 4k. Both k gone, cancel them. It will give you 3 upon. And the last example of question number 1. It is given tan theta is equal to 1 upon 2 root 2. Get sin theta and cos theta. For obtaining sin theta and the cos theta, let us make a right angle triangle here, DEF. Angle E 90 degree in measure, F theta. Tan theta, a ratio of opposite side DE and neighbor side EF. It will be written further DE 1k, EF 2 root 2k, where k is a constant greater than 0. This is 1k, this is 2 root 2k. In order to obtain DF, we will write in triangle DEF, there is angle E of 90 degree measure. Hence, by Pythagoras theorem, square of DF is equal to square of DE and square of EF. This is called as Pythagoras theorem. Now we are going to write DE 1k square of the bracket, EF 2 root 2 k square of the bracket. 1k square will give you 1k square. 2 square 4 and into 2 will become 8. 8k square. How did I square that? I'll show you separately. 2 root 2. Okay. So first square of 2 become 4. Square of root 2 become 2. That gives you 8. And this is 1k square. 8k square gives total 9k square. Now we are going to write df square root 3k. df is got 3k. Let us obtain sin theta, a ratio of DE opposite side and the hypotenuse DF. This is called as sin theta, 1k upon 3k. K cancel them, 1 upon 3. Then you have the last ratio cos theta for this example, the neighbor side EF and the hypotenuse DF. Divide them, 2 root 2k, the hypotenuse is 3k. Here k gone, you get 2 root 2 upon 3.